This is Pre-Calculus A, Unit 7, Lesson 9, Finite Geometric Series. Just a little bit of review. You recall a geometric series is a series that has a starting value, and every subsequent term has a constant of multiplication. 5 plus 10 plus 20 plus 40 plus 80, etc. A series where we add the terms instead of a sequence in which we just list the terms. Okay. In this case, we define our first term, a sub 1, as 5, and our common ratio as 2. Okay. And we define the terms of the series explicitly as a sub n was a sub 1, there we go, r to the n minus 1, or in this specific case, a sub n is 5 times 2 to the n minus 1. Okay, and that'll generate the terms of the sequence. And we can express it with sigma notation. This is the sum from I equals 1 to, well, whatever it might be, to n of 5 times 2 to the n minus 1. Okay, and that would generate the series. Now what we're looking for today is something called the partial sum. We've done partial sums when it came to arithmetic series. We're going to do them with the geometric series. So for example, if I said the sum from I equals 1 to 4 of 5 times 2 to the n minus 1, that would be 5 times 2 to the 1 minus 1, or 0, which is 1, plus 10 plus 20 plus 40. So iterating the index one at a time, we generate these terms. 40 and 20 is 60, and 10 is 70, and 5 is 75. Okay, but there has to be a simpler way. What if I wanted to find the sum of this series for the first 100 terms? Okay, and that's the goal of this particular lesson. There is a formula. I'm going to go ahead and derive it, and hopefully not take too much time doing so. But there's a little bit of a trick to deriving it that's kind of fun. So here we go. So here we go. Let's write the nth sum as this. It's going to be a sub 1 plus a sub 1 times the ratio plus a sub 1 times the ratio squared plus a sub 1 times the ratio cubed, and so forth, right? That's each subsequent term. And then I'm going to write the last 3 terms of the sequence. So a sub 1 r to the n minus 3 plus a sub 1 r to the n minus 2 plus a sub 1 r to the n minus 1. And n minus 1 is the last term of the sequence. Okay, and what I'm going to do is I'm going to multiply r by all of these terms, by both sides. Multiply r by both sides. Okay, and when I do so here, I get this. In fact, let me do it this way here. Well, yeah. Okay, so I'm going to multiply r by both sides. So a sub 1 gets multiplied by r, so I'm going to write that term down here. A sub 1r. A sub 1r gets multiplied by r, so that becomes a sub 1r squared, so that term ends up here. A sub 1r squared becomes a sub 1r cubed, so that ends up right here. And you can see this going on all the way to the end. A sub 1r n minus 4 gets multiplied by r and becomes a sub 1r to the n minus 3. A sub 1r to the n minus 3 gets multiplied by r and becomes a sub 1r to the n minus 2. Okay, and so on. We get a sub 1r to the n minus 1. And a sub r to the n minus 1, a sub 1r to the n minus 1 gets multiplied by r and becomes a sub 1 r, a sub 1, r to the n. Okay, so just multiplying everything by r, and you notice things kind of shift over down and to the right. Okay, what I'm going to do is I'm going to subtract the bottom row from the top. So I'm going to subtract this from the top. So when I subtract, I distribute the negative sign. These all become negative. All become negative. And here's what I get. Here's what I get. All good mathematicians make sound effects when they draw. All right. Okay. So here's what I get. On the left side of the equation, we get s sub n minus r s sub n. Okay. On the top, a sub 1 doesn't have anything to subtract from it, but a sub 1r subtract a sub 1r drops out. Okay, let's go ahead and do that here. Just going to symbolize that. That drops out. A sub 1r squared minus a sub 1r squared. A sub 1r cubed minus a sub 1r cubed. And that continues in that fashion all the way up to here, leaving just the last term minus a sub 1r to the n. And that's where the magic happens. All those terms drop out and we have just the first and the last terms. Okay, let's do a little simplification. I'm going to factor s sub n out. S sub n times 1 minus r. I'm going to factor a sub 1 out. A sub 1, 1 minus r to the n. And then I'm going to divide by 1 minus r. We get s sub n is a sub 1, 1 minus r to the n over 1 minus r. And that is the formula for the nth sum of a geometric series. So let's take our previous example. Our previous example was a sub 1 is 5 and r is 2. Okay, and we want to find the sum from I equals 1 to 100. So we're going to find the sum of the first 100 terms. And we're going to take 5 times 2 to the n minus 1. And the formula becomes a sub 1, 5, times 1 minus r to the n. So 1 minus 2 to the 100 over 1 minus 2. Over 1 minus 2. And interesting, by the way, you're going to end up with a negative down the bottom, but you're also going to end up with a negative on the top. Okay, and let's grab a calculator. Desmos, oh Desmos, oh Toodles. All right, Desmos. Yes, I have young children, so I'm familiar with Disney Clubhouse. All right. Okay, here we go. So 5 times 1 minus 2 to the 100th. All divided by 1 minus 2. 6.338 times 10 to the 30th. Okay, now of course that is rounded. We would have 10 to the 30th means that decimal is going to be moved over 30 places. So it's a very, very, very large number, and that's because exponential, this grows, geometric series grows exponentially, especially when we're doubling each time. And just to give you an idea of the magnitude of that, there are assumed to be about 10 to the 70th power particles in the entire universe. That includes subatomic particles, electrons, neutrons, quarks, strings, etc. So that is an astronomical number. All right, but not a number that could have arrived at by hand calculating, at least not through any reasonable effort.